Welcome to the session Database Management Systems. In today's session, we are going to learn about the fundamentals of data and databases, types of databases, data warehouses and data mining, database management systems, and we are also going to look at certain applications of database management systems. To start with, let us understand what is data. We have been discussing in the initial classes, data is something which is fundamental and data is raw facts. The fundamental unit of data is called as bit, or it is simply called as character. A character is a single alphabet, numeric or other symbol. The next level of character is called as field. It consists of grouping of related characters, like group of characters can be called as field. We will be taking an example and trying to understand this. A group of attributes put together is called as a record. Now collection of records is called as a file, and collection of many such files could be called as a database. We see the hierarchy of how the data is arranged. It starts from bits and goes up to become a database. Now as and when data gets accumulated, it increases its size and the structure. So the database structures, formation occurs in this hierarchy. If you look at the table, we see the table is an integration of a row data and the columnar data. In this particular example, we will try to identify a character, field, record and a file. Now this is a simple table structure which consists of 4 fields. The first field what we can identify is in column 1, which is called as student ID, and that being unique is called as a key field. We have first name, second name and date of birth, other 3 key fields. Now every field represents one type of data there. Similarly, when you look at the horizontal data, let us say the roll number of a student, which is fetching me the complete data, is called as a record. Now collection of many such records is called as a file. Now the data is well organized here. One of the important characteristics of database is it's well organized. It is segmented and arranged systematically. Like what you see in this table, the data has been very systematically arranged in terms of field names and row wise, like record wise. Now when I pick one record, it gives me complete data of one student. We will also make an attempt to understand how this hierarchy helps in forming a logical data structure. Now we saw like byte, bits and other forms. In this particular example, we are able to see the data whatever we are storing is occupying a memory storage, and that memory storage needs to be organized or measured, because as and when there is enormous amount of data generated, like what is happening in today's business, we also need to think about where to store the data, how to process the data. The amount or the voluminous data when it is getting processed might also slow down the business activity. So till now we were only talking about the fundamentals of data. In today's business activities, there is huge amount of data generated every second. Now this data needs to be processed, stored. From that point, this hierarchy becomes very, very important for us to understand how data is stored, where it should be stored and what are the different types of data structures through which we can store the data. Now we'll look into the definition of database management system. A database management system is a well organized set of data organized in a systematic way. A database is an integrated collection of logically related data elements. It consolidates records which is previously stored in separate files into a common pool of data elements that provides data for many applications. Historically, data was stored in file systems. Now these files were stored in different patterns like sequential or indexed method. Now, file systems were major in reporting or storing data or accumulating data in one place. Now, as and when we moved ahead, we started using computer technologies, and with the help of computers, today we are able to create huge databases with the help of ultra-modern memory storage networks. Now, when we look at different types of database structures, we can see hierarchical database, network database, relational database, and object-oriented database. Now, these database structures follow different methods in the way the data is organized or stored. In hierarchical database, data is organized in a tree-like structure, while in network database management system, data is organized in graph structures with multiple relationships. In relational database management system, data is stored in tables with relationships, like best examples are MySQL, Oracle and SQL Server. And we have object oriented database management system where data is stored as objects or object database. In NoSQL database management system, database is designed for unstructured and large data sets. Like in NoSQL, the data might not be exactly in the tabular format. It is more of an unorganized structure of database. Now, we saw these different types of databases. There could be multiple applications of these database structures based on the situation. Now, till now we were worrying about different database structures. When we look at the real scenario, the data created for every business organization varies from one to another. The set of data which is created for a bank might vary from a school or a hospital, or we were also taking in our last sessions, we were considering the examples like hospitals, and in just previous session we were discussing about pharmaceutical companies. Now, in all these cases, the data might be stored in the tabular format, but the key fields and the way the data is organized might vary. And the type of provisions made for this database arrangement, accessing, like it could be networking, security or any of these features vary from one type of database structure to other database. And this purely is a necessity of that business application. We have some of the most popular types of databases in market, like Oracle database, which is most popularly known by many of us, MySQL, then you have SQL, Microsoft SQL Server, Maria database, and we have Microsoft Access, IBM DB2, PostgreSQL and MongoDB database. Let us try to understand the database architecture. A database architecture is depending on its design and can be like following types. It could be either centralized, decentralized or hierarchical. There could also be a three-tier architecture, something like what we see in the diagram, where it is more like a database tier, application tier and a presentation tier. We can further understand this with the help of an example of a database architecture with a diagrammatic representation. Now, when you look at this particular diagram, you understand that there are three layers which we were trying to understand as the three-tier architecture. Now, in the first level, there is database and there is physical schema and a conceptual schema, and then view 1, view 2, view 3 for different users. Now, the first layer is the physical layer where lot of data storage activities occur, and in physical and conceptual schema, the conceptual layer where the data is organized, like logically it is arranged in terms of tables and other structures. Now, how it is arranged there, it could be relational or it could be network, it could have multiple methods. And at the topmost layer you have external layout view for the end users. Now, what the end users see the data is not what it is stored at the very fundamental level. Now let us take a small example for this. As a bank account holder, what data you see is not exactly the data how it is stored. The data there comes in pieces and goes back in pieces. The view what you get is the front end view. Now when I say my login name or password, it is just looking like a two columnar data. Now how it is verified, stored and taken is a part of this data architecture storage. Now we need to understand there are a lot of concepts like security, authentication, data flow. So you have, when you design a database architecture, there are multiple other sort of things like where you are going to store the data, like data warehousing or data inventory. Whenever you want to retrieve the data, you are going to, data mine or data flow, from which point to where it is going to happen. So there are so many things which are part of this database architecture which is not visible in the diagram what we are seeing. So in reality all these concepts are integrated in the database architecture. So today when data has different characteristics, we make use of multi-dimensional formats to store the data. If we consider some of the examples like banking, healthcare, retail, education and social media, some of these sectors are, generating so much amount of data. Millions of transactions might occur for banking, or something like healthcare where every patient when they visit the doctor, there is data generated. Now if you look at how the data is created and stored, there is transactions, data is created in the form of records and stored, and then there is retrieval of data. So there are multiple activities which are happening. Now the data needs to be secured and stored layer by layer, not only in terms of security but also at the comfort of the end user. When they look at some data, they should be able to key in or read or handle it. Now today databases are designed in a very simplified way where the user need not worry how the data is stored. The database administrators take this pain of creating the database architecture, integrating the concepts and maintaining it. Now when we were discussing all these things, we also understood that the data is either newly created or the existing data is modified, retrieved or deleted. Now to do all these activities we make use of lot of data structures. Now from the examples what we were discussing, if we look at something like healthcare sector's data, you cannot delete the data any day and you have to store that data. Now that is not possible in case of banking, because if you are storing the data itself is going to occupy so much space. At some point you need to delete the data. That's the reason in banking sector they say like your data is going to be available for so many days, and still it might be still relevant after some months or years. Now in such situation you should still be able to store the data and access the data. Now these are the practical challenges when data is handled in the industry scenario. In today's scenario, majority of the business organizations are creating huge amount of data. Now there are certain benefits of database management systems and there are also challenges. Now let us look into the benefits of database management systems. Once the data is in place, it helps in making better data decision making. Now it also helps in increased productivity. Now these days storing data is also one of the mandatory thing. It helps in maintaining the compliance, fulfilling the regulations of data management. Majority of the organizations these days are also supposed to disclose their data on the web portals or on their websites. Once the data is stored, it can help us in reducing the cost of data entry, data storage and data retrieval. Further, it helps in improved data access using host and other query languages. It also helps us in improved data security and minimum data redundancy. Till now we were looking at the benefits of data storage. Once the data is there, it's going to be useful from multiple angles. In the managerial systems, it is very useful for the managers once the data is stored to look at the data, to disseminate the data and to facilitate the decision making. Today, information systems' major job is facilitating data on time. Data is not only created but should also be disseminated for the respective departments, units or individuals. Only then it serves the purpose. Now, when we looked at the advantages, in case the organization doesn't maintain the data properly, it is also going to cause certain threats or challenges. Let us look into the disadvantages of database management system. Creating and maintaining data is definitely going to cost. So, it might increase the cost of data creation, maintenance and retrieval. If the data stored is not secured and maintained properly, it might cause data leak or threat. So, one needs to ensure highest amount of data security and privacy when the data is created. It's not only one-time creation, as and when you maintain the data, you need to frequently replace it and restore it. So this also is going to cost. When you say you are creating the data and storing, it also consumes lot of hardware. So you need to keep investing on the hardware. And these days there are modern hardwares which needs to be used for data storage. Now let us look into some of the interesting facts about database management systems. Here are few highlights from this session. In this session, we discussed about the fundamentals of data and database management system, types of databases, data warehouses and data mining, and then we discussed about database management systems. And these are some of the references used. With this, we are going to conclude the session. Thank you.